Yes, my name is Klaus-Peter Klaas. I work at GESIS, and together with Knut, who provided the very nice use case, we tried to actually transform the legacy information metadata that he has in his ZEP survey to DDI. And I'm going to tell you what the steps were, what we did, what we need to do. And if the slides go further now, okay. So the agenda for the talk today is I will present you our DDI suite. So everything that we built around DDI so far. I will introduce the use case called legacy data to DDI. I will give a hint on what the data metadata is looking at. And then I will present our initial REST API to do the transformation, and also show you a short screenshot of the verification of the data, and then some perspectives, summary, and outlook. And I'm going to start now with the DDI environment in GESIS. So since several years, and we presented at EDDI our idea of how to handle DDI in a practical way. And this is the usual picture I hand out every time. So in the middle is our so-called DDI FlatDB. That's the XML storage of the DDI data, metadata itself. And around these are several tools. I will give a little overview. So the DDI suite is built around these central components. That's the DDI FlatDB that holds all the versions and flavors of DDI in a classical relational database. The DDI XML is accessed via our so-called DDI dialect definitions. In there, we model the access to the actual data, meaning that we can specify XPath, etc., in order to get, for example, the title of a study in a study unit section. We integrate all this information in the so-called DDI entities. That's our Java representation of the central DDI elements. In the meantime, almost all. And with this DDI entities in Java, we can read, write, convert, transform any DDI actually like we want. We built some tools and services around this DDI FlatDB. For example, we built a DDI converter that takes DDI codebook and can transform it into DDI lifecycle 3.2. We also, in a project with Chester, created an automated pipeline from harvesting over exporting DDI and putting it into DDI for in our Elasticsearch for searching. We built several DDI indexes, or these two DDI indexes, in order to index DDI data for study search, for variable search, and also for question search. And we are going to have another talk today at noon about the question search part. So feel welcome to visit that talk also. The main component that we build is the questionnaire editor. There you can create and document a study. You can create document instruments, questionnaires, questions, etc. It has several features. I will not go deep into this. Also, there is a talk at 12 in a session where I present the questionnaire editor a little bit more deeply with 3 use cases in the Discovery 2 session. And we also have some experimental tools and services. Currently, we are working on a statistics to DDI. So when you think that you have a full flavored documented questionnaire, it's more or less possible, if also the variables are documented, to read the statistical files, annotate the DDI then with variable statistics. And we also did generate frequency tables, cross tables, graphs, etc. That worked also very well. I will talk today about this legacy bulk import, and that is still experimental, but it worked. I will show you, and also We are currently trying to export from the questionnaire editor directly into Lime Survey or Survey.js so that you can actually conduct the questionnaire online using the questionnaire editor, export everything into these tools, and then run the actual survey. So what is the status quo? We have a lot of service providers in Europe and worldwide that document their survey data, the metadata, on all levels, study information, questionnaire level, variable level, and usually in self-developed legacy software. And there is, of course, the need to disseminate the metadata and data. There is the need to make the data and metadata searchable, browsable, and in the meantime, also you take all a look at research data graphs, so you need to link the data, etc. So what we actually need is tools based on DDI, because if we all stick to the metadata standard, that gives us synergies, cost reductions, because you can reuse certain tools, and at the end, it leads to a better documentation of data. In this talk, I'm going to show you a bit about how the German Institute for Economic Research is running is storing and maintaining the socioeconomic panel metadata and data. And the use case was that we try to convert their legacy metadata directly into DDI, so it can be reused, whatever, sent to Chester for searching in the data catalog, or even put it in our question search tool. And yeah, that was the overall goal, to make it accessible in DDI and then reusable. So the metadata is currently stored in tables with metadata. They have actual CSV files, and they contain all the information on instruments with questions, data sets with variables, the connections between question and variables, and of course the complete DDI hierarchy that you have, study, questions, etc. And they currently edit these with LibreOffice Calc and run it against a GitLab repository, and they really edit the CSV files. You can access the actual data at the GitLab, and of course this is, as Knut put it, an extremely economic setup, because they don't need any further tools. They just rely on the CSV as a basis. Around this, there is, of course, an ecosystem, because they want to do something with the metadata and data. So they develop the questionnaires at the moment with LaTeX and R. You find examples in the link behind the links when we publish the slides. They do translation with Virtal and whatever XLIF is. Knut, maybe you can later on tell me. So this is the German-English translation done. The metadata defines the structure of the final data set, and the Stata ADO files are using this metadata in order to be processed. The data management is driven by the metadata at the sub case, and then they produce PDF codebooks and put the information on the website paneldata.org using these metadata, and that is more or less automatically done. In addition, they use several R packages and variables and various scripts which use these metadata, and the documentation of the metadata structure is done with the same complete system. We have a little example here of the CSV file. So what you see on the left is the question number or question name, the item, the actual text, and they come in German and English. You have also instructions, etc., and even filter filters here at the end, and the answer CSV is then connected via a key with the question CSV. Yes, and in order to get this to DDI, we actually reused our questionnaire editor. And what we wanted to do is we wanted to do it as simple as possible. And that's why you use REST APIs at the moment. We also had thought about getting our DDI entities out to the world, the Java entities, but they are rather complex. And we wanted to make it more simple. And that's why we introduced another object layer based on JSON objects. And that works quite well and removes the complexity to handle also the inherent DDI structure. That's also what the REST API does. It places the things there where they should be, so you don't need to worry about the DDI structure anymore. And of course, if you do it nicely with Swagger in the background, then you can also create your own REST client in your own programming language and start to convert your metadata. The initial REST API looks like this. This is directly from the Swagger interface. So what you can do is you can post an answer, you can post a question, you can post a question grid, you can post a statement, you can create and add a study. And this is how I processed the CSV files at the end. And I just pushed everything into via the REST API, actually into the DDI FlatDB using the questionnaire editor. And so the current workflow is as following. You have your legacy metadata. You create your REST client. The data is uploaded via the REST controller that we developed within the questionnaire editor as an addition. And this leads then to DDI entities, which are then stored in the DDI FlatDB. And what you see below here is the actual outcome. So you see a list of questions here on the left side, and on the right side, you see that we gathered the question pretext, the question text, and of course the answer scales directly. And we also managed to be multilingual, so I was able to upload the German version and the English translated English version. And you directly have actually a visual control of your questionnaires. And yeah, and what can you do then with it? You can either simply look at it, or you can export it again. So you can export your DDI file. There's also a REST API endpoint available to get the DDI. You can, of course, then edit the questionnaires in the question editor. You can also access the metadata back via JSON, so you can read out your data if you want to. And one question is, do we need to export it back to the legacy format? I will come to this at the end again. So here is just a simple Java code. So I needed to read in the files provided by Knut, question, answers, etc. And I created in the second step, I created in the second step the new study. And then I run over all the instruments. So the questionnaires, I selected one here and create the new instrument. And then I run the instrument where I put all the questions into the instrument. And at the end, I can call get XML and I get back the DDI. The question here is then again, okay, from legacy to DDI and back. So what we have built is here, in general, an open source DDI suite, which enables anybody to move to DDI. At least that is our idea at the end. But the reality says, of course, everybody is using a legacy system. And these legacy systems are usually highly integrated. It's not possible to change in one step at one dedicated point in time to just say, okay, we will use tomorrow all the GESIS tools on DDI. I guess that will not be feasible. And because there are too many software components in various steps of the documentation that rely on the legacy data. And I discussed this also with Knut. And I think what we have here is we have a DDI suite that provides a solution to migrate step by step, meaning that you can enter the process, use the open source DDI tools that we have, and then we should think about also have a template to export the DDI to the original legacy system. Because in this way, you could, for example, say, okay, we switch to the questionnaire editor, DDI questionnaire editor. We don't use the LaTeX R environment anymore. We use the questionnaire editor, and then we can still export it into our CSV system, because then we can run all the other processes at the end. So I think this is very valuable to have this way back at the end.
5 minutes.
Yes, this is a summary, Hilde. I'm managing quite nicely, hopefully. So in summary, I presented you very shortly the DDI suite that we want to publish as open source, and you can gain access already. I presented you shortly the REST API to bulk import legacy data. We can convert this to DDI. We have the use case of ZUP. How to do it, and I also made the perspective that maybe we can use all the DDI suite if we work together to integrate DDI into the legacy workflows, and then have a step-by-step migration to build new open source research data, a new open source research data ecosystem. So now it's time for questions. Thank you very much for listening.